So this is going to be a basic project demo of our finished system. This isn't for any testing, but just to show you the way that it works. So we have here our finished box. You can see the BNC cables, power indication LED, a couple of switches to determine whether you're in BNC or 10x probe setting. So right now I'm just going to plug this guy in so you can see it power up. Just connect the basic USB cable here. Plug it into the laptop, and you can see the power indication LED turn on, so we know we're getting power here. And now the first thing we're going to do is just demonstrate a basic measurement of a waveform using a standard 10x probe. We will put that guy on. Connects nicely. And here we have a BNC cable connected to a function generator. The function generator is generating right around a 10 volt peak to peak, 10 kilohertz sine wave. And so I'm just going to hook that up. Connect the witch's hat. Now we've got that signal going straight into our thing. So what we're going to do now is open our software and can you Ubuntu? Here it comes. Alright, there we go. Now if I turn on channel 1, you'll be able to see here, there's our signal. A few of the features of the software. We're on pretty low or high volts per division here, so the signal looks a little smaller. If we crank it up, the signal gets bigger. We can even go one bigger than that. Show you. There we go. And now instead of free run mode, we're going to have it trigger on, say, the rising edge. And we'll change our horizontal scaling to something a little lower so we get fewer waveforms. So there we go. That's about a little over 5 periods of our waveform there, triggering on the rising edge. And now I can switch the triggering to falling edge if you prefer. See the falling edge trigger. And I can adjust the trigger level here dynamically. And you see you see it shifting there. Now we're triggering at 1.5 volts, all the way up to right there is 4.5 volts, almost at the top of the 10 volt peak to peak signal. And again, I can go in the other direction if I prefer. So you have dynamic triggering here. This will work on both rising and falling edge. And there, oops, keep going down. Now we're triggering around negative 3.5 volts. So that's a pretty good demonstration of what's happening on one channel. Now on the other channel, if we wanted to hook up a second signal, as you can see right here, we have a second signal. It's just floating because nothing is attached to it. So what we're going to do is we're going to use a couple of BNC breakout cables, and we're going to have to use a second Mikhail's hooking it up for us, second function generator. We're going to try to get that as close to 10 kilohertz as we can so that we can, even though we're triggering on one signal, we can view both of them at the same time. So we're going to hook up this BNC breakout probe to our oscilloscope. And since it is a BNC breakout probe, we're going to need to switch over this setting to the other setting towards the outside. And we're going to hook this guy up. What voltage are we at? About 10 volts there too?
A bit above 10 volts.
Okay. So we have it on the BNC probe setting. Now we can come over here to our fancy software. Check out the triangle wave on the second division. Again, it looks a little smaller, but we can crank it up, make it bigger like the first one. There we go. And since we're triggering on the first wave, you can see the second wave kind of rolling by. The frequencies aren't exactly the same, but we can again increase both the individual volts per division for that, make it look bigger. Here's the 1.6, so we're taking up almost the entire thing right there. Now we can lower that back down. Horizontal scaling works just the same. So now we're zoomed way out. Still triggering on the falling edge of the one waveform, but we have the second waveform again floating by. We could turn off the first channel if we wanted and watch the second channel go by, turn the first channel back on, turn the second channel off. It doesn't really matter. Basically what I'm saying here is that we have both 10x probe and a BNC capabilities. Both of them we can individually view the volts per division, amplify it up if we want to, viewing two different signals at the same time on the same graph. But you guys have anything else to add? Yeah, okay, so now if we wanted to, we can export a ping image. I'll hit stop here and export a ping. Now I can call it whatever I want. Test.ping. And we'll save that to just to the desktop. How about that? We're going to export our ping image, well, I'll export a CSV while I'm at it. Also to the desktop, we'll call that test.csv. And so now we're going to have a comment separated value form and a ping form. Now I'm going to close this out because I think we're done with this software here. And I'm going to go show you what we got. So our test ping is just a ping image of that waveform. And at the bottom here you can see that we're showing the volts per division on both channels and what the time per division was, which is 256 microseconds per division. So that'll give you just an image of the waveform if you needed that. And then, what should I open this with? We'll open up the CSV here to show you the comma separated values if you wanted to work with this in either OpenOffice, or we've been doing a lot of ours in MATLAB. So we have opening it with comma separated values there, and we'll open that up. There we go. So now you can see what the voltage was here at all the times listed on the right-hand column. We don't have channel 1 values right here because we didn't have channel 1 selected when we exported the ping. We only just had the one waveform. So if we had channel 1 in there, we would have had that as well. I'll show you the sampling rate here, which is at 1 megasample per second. And all the voltages as we go along here, you can see for the entire sampling time period. So that's about all the functionality of our product. We hope you've enjoyed the demo, and if you want more information, you can look at the rest of the pages on BeaverSource.